Hello everyone, my name is Moupiya Maji. I am a researcher in the Office of Astronomy for Education or OAE Center India. I am based in IAU Institute and in this talk I will present our project on baseline survey. We are doing this survey to find out the status of astronomy education in India. Astronomy education at the school level is important because it is a unique subject in many aspects. The vast spatial and temporal scales of astronomy can give students a much broader perspective. It can demonstrate the interdisciplinary aspects of science, and above all, it can inspire students to connect better with science subjects in general. However, this potential of astronomy has remained severely underutilized in India. In the school syllabus, astronomy content is very limited. It is generally taught as scattered chapters in science, geography, or environmental science book, and that too mostly just till class 8. Our overarching goal is to improve astronomy education in schools. The workflow to do this can be divided into 3 steps. First, we need to evaluate the current status of astronomy education. Then, based on the evaluation results, we identify areas that should be improved. And finally, we implement these improvements to build a better curriculum and develop effective teacher training programs. The baseline survey belongs to the first step. This survey is geared towards 14 to 15-year-old students, which is class 9 in India. It is a 16-question instrument that probes 5 themes: students' perception of the current astronomy content in their curriculum, their general astronomy knowledge, cultural connection with astronomy, access to resources, and their further interest in the subject. We conduct this survey with students in class 9 because most of the astronomy content is covered by grade 8. We also interview science teachers in the schools to know their views about the merits and challenges of teaching astronomy. The survey is completely anonymous and we take informed consent from all participants, students, teachers, and school principals. We obtained clearance from our ethics board to conduct the survey nationwide. To do this survey, we have gone to the schools in person and give each student a printed copy of the questionnaire. The first part of the first page is the student consent form where we tell them what the survey is about and inform that their participation is completely voluntary. Then we collect some demographical data. The initial version of the survey questions were inspired by discussions with teachers, students, and researchers, along with other astronomy education research surveys. We also made sure that the questions reflect the Indian context properly. Before rolling it out nationwide, we conducted a pilot study where we surveyed 270 grade 9 students from 2 schools. We analyzed the responses and based on student feedback, the survey questions were refined and we arrived at the final version. None of our questions are multiple choice. We give students space to write whatever they want as responses. This elicits more organic and true answers from the participants. We wanted to collect responses from a diverse range of students. So, we have conducted the survey in 11 states in 10 languages. The survey has been done with approximately 2,000 students in about 30 schools nationwide in a variety of environments such as urban school, rural school, different school boards, medium of instruction, etc. The full analysis is ongoing. Here, I will show results from our preliminary analysis with 652 students in 8 schools in the state of Maharashtra in Western India. We start with a couple of general questions. We ask their favorite subject and almost half the students mention science. We then ask if they like learning about astronomy in general, and find that 82% of students do like the subject. Then we ask them 3 questions about astronomy in their present curriculum. First is, among the astronomy topics they have learned in school so far, what were the most interesting ones? These are all freehand questions with no choices given. So we received a wide variety of responses. After we categorized the answers, we find that students like the topics about solar system, stars, and popular astronomy, such as universe, black holes, etc. Then we ask what topics they found to be the least interesting, and most people said moon phases. This is also a top choice for the hardest topic. Many people also said they didn't find anything particularly hard. The next few questions probe their general astronomy knowledge about distance scale, mass scale, and moon phases. Here, the first one asks them to arrange the objects Jupiter, Moon, Earth, and Sun from smallest to largest. In our sample, 601 students answered this question. Only 60% of them answered it correctly. That is, the order is Moon, Earth, Jupiter, and Sun. The next 2 top choices were Moon, Jupiter, Earth, Sun, and Jupiter, Moon, Earth, Sun. So it seems like students are confused about the size of Jupiter in relation to others. The fourth choice is the reverse of the correct choice. These students probably just misread the question. We then ask them to arrange the objects Sun, Moon, stars, and Neptune from nearest to farthest. Here we find that only 32% of students have answered it correctly. Looking at the next 3 top choices, we find that students are mostly confused by stars. The Moon, Sun, and Neptune appear in that order, but 18% of students put stars in the second place, 9% put stars in the first place, and 7% have put it in the third place. This shows that the vastness of distances to stars compared to the size of our solar system is not reaching the students. They have not grasped the ideas of distance scales very well. Next, we give them 9 different moon drawings and ask them to choose the correct image for the given phases of the moon, such as the new moon day or day 1, day 2, day 8, day 11, and the full moon day. About 80% students can identify the new moon and full moon drawing correctly, but only about 1/3 of students can identify the correct moon image for day 2 or day 8 or day 11 in the lunar cycle. There is a lot of confusion about the shape of the moon in different phases. Looking at the overall data, we find that only 9% of students have answered all the phases correctly. This shows that the moon phase concept is not clear to students. And most likely, they don't carry out moon observations over a lunar cycle, which is often prescribed as a suggested activity in their textbooks. In the next couple of questions, we explore their cultural connection with astronomy. A majority of Indian festivals follow the lunar calendar. So, in this question, we ask to name some festival on new moon and full moon day. We want to see if the students can connect their cultural festivals with the astronomical moon phase concepts. Among the respondents, about 65 to 70% students can name such a festival. Interestingly, we find that a large fraction of students did not answer this question. From our interaction with students, it also became apparent that a large fraction of them are totally unaware of this connection. Such things should be emphasized more in the curricula though, to engage students more effectively. Belief in astrology is also prevalent in a large fraction of the population. So, we ask a question about this to study students' beliefs. We ask that a person named, say, Ramesh cancel his vacation travel plans after reading his horoscope. Would the student do the same? Why or why not? About 500 people answered this question, and 76% of them responded no, they would not do the same. The most common reasons stated were that horoscope is a superstition, it is unscientific, or that they don't believe in it. The 24% students saying yes stated that horoscope is either right or they believe in it because everyone else does. This is a good response from our survey population that 3/4 of them don't believe in astrology, but there is a lot of scope to more directly discuss in the classroom about why astrology is a pseudoscience. Next, we ask about their exposure to astronomy related resources. For example, if they have any other resources besides textbooks. The most popular choice is YouTube, followed by books and internet. When asked how many stars they can see at night, most students said infinite or uncountable, which is actually not the case. About a quarter of students reported that they saw only a few stars. 11% of students mentioned pollution as the reason for this. To gauge the students' access to astronomy observation facilities, we asked if they have ever looked through a telescope. We found that only 34% of students have done telescope watching. Also, only about 23% of students have ever visited a planetarium. Most of the schools being analyzed here, that is 7 out of 8, are located in big cities. Even so, the access to such resources remains very low. To solve this, we need raised public awareness to go to the existing facilities and more governmental resources like funding and telescopes to build more facilities. Finally, we asked about their further interest in the subject. We asked them what other astronomy topics they would like to learn about. The most common answers are planets, black holes, and galaxies. These topics are not present in their current curricula, and they could be great additions in the future. We can also use these topics to introduce concepts in other subjects. For example, when teaching refraction of light, we can bring about the idea of exoplanet observation techniques, where refracted starlight coming through a planet atmosphere can be observed and give us insight into other planets. Thus, we can use the students' interest in the exoplanet topic to teach about light refraction and physics more effectively. Finally, students are asked if they would like to learn more in higher classes or in college, and about 3/4 of them expressed interest. When asked if they would like to be an astronomer, about half of them says yes. We also want to know if they are aware of the career path to become an astronomer. So in the last question, we asked pointedly that if a person, say Asha, wants to become an astronomer, what course of study would she have to choose after school, after college, and further on? Almost none of the students could answer this question at all. This clearly shows that students have a very limited knowledge about how to pursue a career in astronomy, even though many of them are interested in it. These discussions need to be a part of the classroom. So, to summarize, we have conducted a baseline survey of astronomy education in schools across a variety of settings. Our preliminary analysis shows that although astronomy is a fascinating subject for students, Basic astronomy concepts like sizes, distance scales, and moon phases still remain poorly understood. We will run the full analysis with all the data soon. In the next step, we will look further into the data and analyze if the gender of the students, the socio-economic background of the schools or medium of instruction, that is English medium versus vernacular, affect the statistics in any way. Results from this survey will help us to identify the gaps in student understanding and thus guide us to design effective teacher training programs and help us to create an improved astronomy curriculum. Thank you very much for your attention.